Yeah. Yeah, so let's solve this quiz that we just took. And yes, now the attendance has a new column saying course handling faculty that I added yesterday. I thought everybody was from Rajesh class, but there are other faculties that. So just make sure you select the right one, because the attendance is the only thing that faculties get that I can send them. And so make sure you do your attendance. Okay. So so it's not quiz one, right? It's quiz two. And let's put, okay. First question is, an IPv4 address is a dash bush address that uniquely defines a connection connection to the internet. So this is direct memory based IPv4. How many bits? 32 bit. And just since we are doing this, let's just IPv6, 128 bits, right? So this first question was direct memory based question. There's nothing that you need to do. 32 is your right answer. It's now all these are not right. Okay, so let's move on quickly. So this is question. This is one. So 32. Okay. Next question. Dash was developed as a long-term solution for the issue of address depletion. So what is address depletion? Address depletion means you had an address space of some whatever length. Let's say here in the whole address space you had 4 spaces. So you had 4 sub addresses. And let's say you had 3 entities and that took the first 1, 2, and 3. So this is not a problem. If you have 4, then all 4 will be taken. But what if you have 5? Then this does not have a space. There's nothing. So this fifth node will not have an address. So that's what address depletion is. This is a depletion in the amount of space required for all the nodes. And what is the solution for this? You have subnetting, IPv4, IPv6, and TCP/IP. TCP/IP is a solution, is a protocol. It's a protocol for routing packets, not for address depletion. It's one of these 3. Now, if you look at subnetting does not deal with address depletion. What subnetting does is you have an entire address. Let's say it's here. Let's say it's the whole 128 bits. 28. You will divide a certain part. Okay, this is subnet, and this is for node. That's it. That's what subnetting is. So if you have a school, it'll all have the same subnet address, but the node addresses would keep changing depending on whichever node it is. Right? So it's not so subnetting does not take care of address depletion. And between IPv4 and IPv6, we can see here. So IPv6 was developed so that because that IPv4 did not have enough addresses. So here the answer is IPv6. That's all. Okay, so IPv6. This is question 2. Next. The dash address in the block 255.255.255.32 is used to send a datagram to all the devices inside a network but not outside. That means you have nodes and you're using this address and it sends to all, right? 255, 255, 255. When you see this itself, you should think of one thing, which is broadcast. Broadcast. So as soon as you see it, you need to know it's one of the broadcasts that we have. Broadcast. It's not unicast because that is not to all the devices. It's not unicast. It's not multicast. Multicast would be to many, but not to all. So answer is either local or limited. And there is nothing called a local broadcast. Local broadcast in networking, there's nothing called local broadcast. Limited broadcast is what is the answer. And why? What is limited about this? It's only inside. It's only inside the network and not outside. So that is what makes it limited. That's it. That is the answer for this question. So that is question number 3, limited broadcast. Okay, next. Let's go question 4. A packet with an address block 127.0.0.8 will have the same destination as dash. So every time you see, we saw previously 255 or 255 or 255 or 255, immediately you should know it's broadcast. Broadcast. Now when you see 127.0.0.0, this you will know this is the home address, or what we call the loopback address, right? So in a loopback address, what happens? You have a node, it sends it with this, it's a loopback address, LA, it loops back. So the source is what? This node. The destination is also this node. A default gateway, no. Same host, maybe. Same subnet and a remote server. So it's not a remote server, it's not a default gateway. Because the default gateway is not your home. So it is the host that send it that is going to get back the block. Why not subnet? In a subnet, so you have again, so you have an address, you have a subnet, then you have a node. Next class, we'll actually see more questions related to subnet and node. But one subnet can have many nodes, right? So subnet is constant, and the node is the thing that's going to change depending on which node is connected to it. So that is what is going to change. But a host, this is singular, it's just one. That is what makes this the correct answer. Host. Okay. The same host. So that was question 4. Question 5. Okay. Time to live field defines dash number of hops visited by the data. Time to live. So time to live is where you find it in the IPv4 header. And what this says is if the packet has that much time to live. So let's say if the time to live was 4, the packet can make 1 hop, 2 hop, 3 hop, 4 hop. That's fine. As soon as it makes the 5th hop, kill it. The packet is going to be resent. So when the 4th hop happens, the sender will send it again. And then 1, 2, 3, 4, it will reach. So clearly, it's not the average. It's not the absolute, right? It's a range. It's not the absolute also. It's either the minimum or the maximum. So a packet will go from one node to another in one hop. So that you don't need to specify the minimum. What you don't need to specify is the maximum. So what would happen if we didn't have a time to live? The packets will just keep on hopping all over, and they may get lost and the sender will not send it again and you lose a lot of data. So that's why we needed a time to live. So maximum is the correct answer. Maximum. Okay. Next. This is a question I didn't check, but I think some of you have got it wrong. I can actually check module 4. Frequently missed. Okay. Yeah, so this is the question that we saw before. The dash address. That was not the local, not the limited. Yeah, not the local broadcast, but it is the limited broadcast. Okay, so this question, so let's go to the next question. Sixth. Yes. The third bit in the flag is called the more fragment bit if its value is 1 it indicates that dash. So in the flag we saw yesterday we had three bits of the in the flag. This is again in IPv6, IPv4, sorry. So these are the flags. The third bit is if whether there is more. It signifies that this is a fragment and after that there are more fragments. So when the receiver sees this flag, it will know that there are more things coming. That is what is basically there. So if the more fragment bit is set, does it mean it has an error? No, it has nothing to do with the error. It's talking about more fragments. It is a fragmented, it's like an acknowledgement. So it's not an acknowledgement. So the only question would be whether it's fragmented or whether it's not the last flag. And the thing is, you have to remember that we have bits in the flag to say that it's a flag, right? These two bits will tell you whether the packet is fragmented or not. But that last bit is specifically to know whether there are more packets coming. So that's why the answer is it is not the last flag. Okay. It's not the last flag. Next. Seventh question. If consecutive sections consist of zeros only, an IPv6 can be abbreviated using zero abbreviation, truncation, compression, suppression. So here you have to remember that it's called zero compression. It's not truncation, you're not truncating anything. It is you might get confused with abbreviation. Even suppression is all sounding similar. But the term for this in IPv6 is zero compression. And to give you an example of what is this, we saw in yesterday's session also. If you have A, B, C, D, 0, 0, 0, 0, 0, 0, 1, 2, 3, 4, 0, 0, 0. This can be compressed as A, B, C, D, double colon, 1, 2, 3, 4, colon, 0, 0. So if you have more than one number of zeros, of sections with zeros, that can just be truncated as double semicolon. But if you have single, it doesn't make much difference. So you can keep everything. Also, leading zeros are also removed. So for example, if you have 0, 0, 0, A, B, C, D, this can just be written as A, B, C, D. Right? You can remove the zeros, the leading zeros. But here it is not about leading zeros, it is about consecutive sections. So it's zero compression. So this is something you have to remember. This is also something that you have to remember. Okay. So zero compression. The eighth question. To specify the prefix length in classes addressing, dash notation is used. So if you go back to one of our questions, we saw this in one of the questions. Yeah, you're given a loopback address and the address and this slash. What does a slash mean? I was talking about subnets. So that is the length, how big the subnet can be. And if you're a node, if you need an address, you would need to know how much. It's, for example, you have total 128 bits, 128, and an address says /80. That means what does that mean? What does that mean? That means for subnet address, that is for this one, subnet address, you have 80 bits. And how many do you have for node then? 128 minus 80. That many number of bits. So subnet you have 80 and 48. So and subnet, so you have 40. If you're a person who is making a network and you need addresses, you need to see that you have 48 bits. So 48 bits address you can give yourself. Right? So here the answer, prefix. What is the prefix? It's the subnet. And in passes addressing, dash notation, the answer is slash. Periods are used where in IPv4 we saw 127, period 0. This does not specify any length. Single semicolon we saw in IPv6 a, then colon, and then something else, and then colon, and then something else. Double semicolon, what does it specify? We saw just now, 0 compression. So the answer is slash. Okay. Ninth question. So this one is slash. In classical addressing, class E is denoted by an address that begins with dash. Class E. So you have to know there's A, B, C, D, and E. And in E specifically is a reserved class. It's only for research. And just by looking at saying that E is the last, this should give you an idea that. But it'd be better if you memorized. E is 111. Okay, and these are reserved classes. This is for research base. That's why there you don't see, you don't you will see a lot of 1101s, you'll see 0011, but you won't see a 111 unless you are working in network research or something like that. Right? Okay. So 111. Next question. This is a nice question. Dash is the primary reason for creating a datagram. So all this talking about packets and everything that we have, what is the reason we are creating all this? Why do we need packets? Why do we need datagrams? It's because that you want to send information, info, data. These are the things that you need to send. That's why you're making packets so that you can send it from one place to another. So it's the date, it's the information that is the most important thing. Whatever the protocol is, whatever the address is, if the info is wrong, if there's no info, there's no point of sending the packets. So that is your answer here. It's not the protocol, it's not the header. Addresses are important, but the reason why you have addresses is because you want to send the payload. Payload is another word for the data that packet is carrying. So packet will have all addresses, headers, protocols, everything, and then its major thing will be a bag of data, right? So that's the answer. That's payload. I think we have answered everything. Mm, yeah, okay, let's submit. And I think this time it should have said this course. I'm sorry, last time I did not enable anything. Enable the reviews, but this time it is. Okay, right. So I'll just I'll just remind you everyone to fill the attendance, and that is all that we're done for this session. Right. So I think from here I can see maybe types of addresses maybe we could do in the next class, and maybe even subnetting. We'll see in the next class. Anyway, that is all for this today's session. Let me stop recording.